Hi, this is Joe Campbell. And in this two-part video series, we're going to be taking a look at what I like to call making authentication smarter. In particular, we're going to be using the Cloud Access Manager product to do simple authentications, and we're going to find that some of the applications I have secured are using multi-factor authentication. Now that's great for a lot of the use cases that our customers want to see. However, we're going to present an alternative to the traditional implementation of multi-factor authentication in what we refer to as an adaptive authentication engine or using our risk engine. So let's take a look at exactly what I'm talking about. So how do people typically handle multi-factor authentication? Well, again, let's look at a really traditional scenario. A user connects to a secured application, they're given the two-factor prompt, they generate a key, they enter the key, they use the app. They close their browser, they go access the secured application again, they're given a two-factor authentication prompt, they generate a key, they enter the key, they use the app, they close the browser. And this basically continues over and over and over again every single time someone tries to connect to that secured app. And what we're asking is it necessary that we have to do this every time? And a lot of our users don't think so. Well, what do we know about this user when they connect? Let's take this user here. He connects to a secured application. We see his IP address. We see the time of day, maybe, that he's coming in, maybe business hours, or maybe it's always around 10 o'clock at night. We see the type of browser he's using and the browser that he's using. And we see the application that he's asking for. Well, what about the next time this person connects? Well, we see his IP address. Nothing's changed. We see the time of day he's connecting. Nothing's changed. We see the browser he's using to connect. Again, nothing's changed. And finally, he's connecting to the same application he was before. The moral of the story here is that nothing's changed. What if we could pay attention to the fact that nothing changed and use that to make authentication decisions more intelligently? Well, the Security Analytics Engine, what we refer to as the SAE, was introduced in version 8 of Cloud Access Manager. It enables risk-based authentication in Cloud Access Manager. We make intelligent real-time authentication decisions based upon a number of factors. We're going to get into that a little bit later. And really, we implement two-factor authentication elegantly, not with a hammer. It's built on a plugin architecture, so let's take a look at that plugin architecture. We ship out of the box with a blacklist provider. And you can see what it says here. The Blacklist Provider plugin provides a set of default open source blacklists, optional Dell SecureWorks blacklists, and the ability to add additional blacklist sources. In the demo I'm going to show in the second video, you're going to see that in action. Behavior trends. We mentioned things like IP address, time of day, the location I'm connecting from, the browsers that I'm using, etc. Basically, we take all those behavior trends about an individual. We're looking at a specific person, and we're saying, has anything changed? Take, for instance, a person who connects from home every day in that little circle diagram that we saw before. If none of those behavior elements have changed, then maybe we can draw down our multi-factor authentication and let that person through without a multi-factor challenge. But then that person takes his laptop, drives over to a coffee shop somewhere. What changed? Well, the IP address changed. Everything else remains the same. That could come into our system and be seen as a risk, right? There's something about this person's location has changed. What if the location change is even greater than that? We have a geolocation plugin. This one I find particularly interesting. And basically what it says is, I see you logging in from San Francisco today. And then 5 minutes from now you're logging in from Dallas. Well, we actually calculate the reasonable time it would take for you to travel from San Francisco to Dallas. And if it's 5 minutes, I can tell you that's not reasonable. So if it's something more along the lines of 8 hours, maybe that's reasonable. So even that's going to come through and be seen as a risk in our environment, something that you can respond to intelligently. Malware detection. We have an integration with our SonicWall firewall appliance. SonicWall is going to say, I've identified certain computers on the network that are either malware hosts, or I see virus signatures coming from this machine, maybe it's trying to contact the mothership, etc. That's going to get picked up by the SonicWall appliance, and SonicWall is actually going to tell my risk engine when this person tries to connect, hey, this person's already been identified on the network as a threat. And again, we're going to respond to that elevated risk intelligently. And finally, what about custom plugins? In the current version, we don't support custom plugins. However, it is on the roadmap, and it's something we do want to support. And Why is that relevant to you? Well, take for instance a financial company, someone on the stock market, let's say, and they want to build a risk profile based upon the fluctuation of the stock market. Well, that's not something we have built in today, but that's something that that company may want. All right, or maybe it's a military organization. They want to elevate the risk based upon the current DEFCON status. These are things that are business-specific risk drivers, and when we implement the support for custom plugins, our customers will be able to write whatever risk profile they want to write. So how does the risk engine work? Well, you know already that the plugins are capturing things like user forensics, time of day, geolocation, browser technology, etc. It's bringing in context, what application is being asked for, and of course it's bringing in network data, the IP address, SonicWall information, etc. All this information is fed into the security analytics engine where it's analyzed, and we output a risk score. You can have a low risk anywhere from 0 to 2, and these numbers are actually changeable. An organization could say we want low risk to be 0 to 1, or we want it to be 0 to 4. Everything's changeable in this environment, but just take this as an example so far. We say a low risk is anywhere from 0 to 2, a medium risk is anywhere from 3 to 5, and actually a high risk is going to be hard-coded in at 6 and 7. Now that we've got those values, we're going to make decisions, right? So we could say, let's allow access for anybody that's 0 to 2. But for 3 to 5, I'm going to do step-up authentication. And for 6 to 7, I'm going to block that access completely. Now, what if you don't have a multi-factor solution? Well, maybe you would take that block access decision and you would extend it to 3 to 5 as well. Or maybe 4 to 5 or 4 to 7, you're going to block access, and anybody less than that is going to get access. So, I mean, basically the decision is something that you need to make, and you can make that decision with a combination of a number of different factors. And we're going to see that demo in part 2 of this video. But before we do, let's take a closer look at how we integrate with SonicWall. Basically, we're going to use the malware detection plugin. Think of the systems that are at your company and the fact that the signals that are traveling through the network are basically going through the SonicWall firewall device. At any one point, one of these machines may become infected, and when that happens, SonicWall is notified, and SonicWall sends that information over to the Security Analytics Engine. Well, that's it for the introduction into the Security Analytics Engine. I hope you watch part 2 of this video series where we actually take a look at this in action.